All right, we are live, everybody. So hello, everybody, and welcome to another OWASP Toronto chapter meetup. My name is Adam Greenhill, and I'll be your host for this evening. Just to give everybody a little bit of time to, trickle in, we're going to have a little bit of a pre-show banter with our special guest, Jeff Williams here. And Jeff has over 20 years of security experience. He's the co-founder and CTO of Contrast Security, and he's been involved with OWASP since, pretty well the beginning here. So, Jeff, how are you doing?
Doing great. Thanks, Adam. Nice to be here.
Yeah, it's great to have you. So you served as the chair of OWASP back in 2003. What was the project like, way back when?
Yeah, well, when I joined, it was really just a mailing list. And there were, I don't know, maybe 20 people, something like that. And I was working on something called the OWASP Guide. And it was, it was interesting to have a group of people to collaborate with in a very new space of security. And so I had been working on a training course for application security and had built something I called Attacklet back in those days, like Servlet, but Attacklet, which was a terrible name. And I offered to donate it to OWASP as WebGoat. And so that really got a lot of great attention. And people really liked it. They were playing with it and learning about AppSec. And so I kind of got addicted to it. Like, it's really interesting to contribute things to open source, have a lot of people use them and get a lot of feedback. And like, that was super fun. So later that year, I was going to the federal government in Washington, D.C. and trying to tell them about AppSec. And they weren't having it. They were working on the SANS top 20. And I was like, man, we need a top 10 list of our own. And I was like, oh, maybe I'll just write one. So I wrote this top 10 list and I put it out there, and man, that thing went crazy. OWASP got slash-dotted, if you remember what that is. And we got knocked off the internet, and like, it was really fun and interesting. And so then, Mark Curfey, who was the original leader, walked away from the project, and I took over, and they wanted me to be the global chair. So I did that. And my whole goal was to make it into a self-sustaining organization, like something that would live even if the current players went away. So I set up the board, and I set up chapters program, and actually Dave Wickers, my business partner at Aspect Security, he set up the conferences program, and we set up working groups, and I built the wiki. If you remember, OWASP used to be a wiki. Now it's on.
That's right.
Yeah.
The wiki was a little easier to use. So, like, I don't know. We set up a lot of infrastructure to try to make a really different kind of organization.
That's really interesting. I mean, like, I guess the OWASP top 10 these days is kind of a survey-based, kind of review. But how did you guys choose the original OWASP top 10? Was it also kind of a survey, or what happened?
Well, it was a little less scientific. It's not really a survey today. It's really, I would say, it's data driven. Like they get data from tons of different companies, including Contrast. But in those days, we were relying on a much smaller data set and a lot of intuition. So we had like the work that we did at Aspect, which was, doing pen tests and code reviews and so on lots of applications. And, we made some good judgments about what needed to go in there. And, frankly, I'm pretty happy with what we put in the first one. Now, 20 years later, it's still the same shit. So, I guess we were pretty close to the mark, Yeah. This is funny. I was really intending the OWASP top 10 to be a floor. Like, it should be the minimum that people should eliminate from their applications. And, we're nowhere close to that today after 20 years. Really, the top 10 has kind of become a ceiling, which is really scary. So, if you go out there to set standards, you got to be really careful about how you do it. I expected a lot of these things to get stamped out many years ago, and then we would be adding new things to the OWASP top 10 and raising the bar. But we haven't gotten to the raising the bar part yet. So that's unfortunate.
Yeah, that's really true. I mean, yeah, even in my career, which is, like a fraction of yours, I still see the same issues that I saw like 5 years ago when I started, But like, where do you see that? Yeah, I mean, where do you see the OWASP, body going from here? I mean, it's pretty ubiquitous already.
Oh, well, no. So look, as much as I respect all the people that have participated in OWASP and all the good work and really incredible things that have come out of OWASP, we haven't made much of a dent at all. I mean, Agile movement got started roughly the same time frame as OWASP and transformed development. And then DevOps came, years later, and transformed development again. And, OWASP is still sitting at the starting blocks. The average application today has basically the same number of vulnerabilities that it had 20 years ago. We haven't made progress. And, it's really disappointing to me that we haven't done a lot more, because the situation is untenable. We're building critical systems, like oil pipelines and, election systems and energy systems and power grids and all this. And, we're not very good at building secure code. So, is OWASP ubiquitous? No, not a chance. We need to affect every developer writing every line of code everywhere. And we're not anywhere close.
Yeah, I guess that's part of your presentation today is that including security in the development itself, which is something that we're still not really doing today. So
yeah, for sure. We'll talk about that, but it has to be automated because the scale we're operating at with almost 30 million developers in the world is stupefying. The amount of code that's being produced is bananas. It has to be automated. It has to be accurate. It has to be easy, and we've got a long way to go.
Yeah, well,
so
yeah, well, we look forward to the presentation where you talk more about that. And with that in mind, I think we're good to go. But before we do, just a couple of housekeeping items. For starters, if you have any questions or comments about the presentation, feel free to leave that in the chat, and we'll be periodically monitoring it and telling that to Jeff. If you need CPE credits or you have feedback, please use the link in the description below. And if you're looking for work or you're hiring, please discuss that in the chat now. Are you good to go, Jeff?
Yeah, always.
Awesome. Let me pass over the reins to you. If you want to just share your screen. I think you accidentally closed it.
What do you mean? I did turn it off so I could see everybody.
Gotcha.
So I'll reshare it now.
Yeah, that'd be great.
And then we'll just go to my presentation.
I can see it now. Yep.
All right.
Awesome.
Floor is yours, Jeff.
Thank you so much. Sorry to bore you with the history there. My name's Jeff Williams. I am the co-founder and CTO at Contrast Security, and I've been doing application security for over 20 years now, sort of since it was a thing. And I'm really excited to talk to you today about something called instrumentation, particularly security instrumentation. And by the way, Contrast is hiring. We are a AppSec platform vendor, so we sell tools that do testing and library analysis and even runtime defense. And we are about 350 people now, and we're growing really quickly. So we'd love to talk to you if you're interested. So look on our site. There's a careers page there. So sorry for that. So I'm excited to talk to you about instrumentation today. This is a technique that I helped to develop and bring to market. And I'm going to share some open source things about it, what you can do with it. But really what I want to try to do today is spark your imagination. I want you to think about how we can do better at application security, how we can scale AppSec programs for real in the real world, not on one app at a time, but on hundreds or thousands of applications in parallel, because that's what we need to do if we want to actually change the situation in the world. So I've got a few slides, but I'm going to be doing some demonstrations, so I'm going to jump back and forth. I did want to kick it off with some facts about application security. So a lot of this came out of our AppSec observability report, where we analyze data from tens of thousands of real applications that we're working with. And you can see, 90%, 96% of applications have vulnerability. Interestingly, projects are introducing like 1 or 2 new vulnerabilities a month. And actually, when you think about it at that scale, that doesn't sound terribly difficult to deal with. It's if you let them pile up and you have a backlog of 20,000, 30,000 vulnerabilities, it starts to get really expensive. But if we have a process that deals with it as it goes, we can make this work. So look, the average application has like 30 vulnerabilities, and several of those come from open source libraries. That's nuts. That's a crazy level of vulnerability. I mean, can you imagine if every time we did a safety check on an airplane, we discovered 30 safety violations? Nobody would ever fly. It's crazy. So, we have to do a lot better. These systems that we're trusting are they're the online banks where you do your banking. They're the investment companies where you have your portfolios. They're your healthcare. They're your government. They're your military. These applications are riddled with flaws, and it's not sustainable. So open source is an interesting area. I helped add the use of vulnerable open source components to the OWASP Top 10 back in 2013. It's something I've studied quite a lot. One thing we learned at Contrast is that 62% of open source libraries are never invoked by the application that they're part of. And that really happens because, as a developer, you bring in a library and you use one function out of it, but it might have 10 more functions, each of which has their own dependencies. And so there's huge chunks of the tree that never get invoked at all. And that actually is a huge cause of false positives. It means that people are running around trying to replace libraries that don't need to be replaced. That's the vulnerability side. So yeah, we're pretty vulnerable, but that might be okay if there weren't attackers out there. Unfortunately, the average application is attacked over 13,000 times a month. It's a lot of attacks. Now, most of them miss their goal. So you can see here, 98% of attacks don't connect with their intended vulnerability. So these are, scans for command injection that don't reach an exec. These are SQL injection attacks that don't reach a database, or XSS attacks that never get put back into the HTTP response. All that kind of stuff. But we do see this trending up. So, 2% of 13,000 is still a decent amount of attacks that hit their target. So we've got some work to do. And this is across, again, tens of thousands of applications. So there's a lot of attacking going on out there. If you don't have visibility into that, that might be a problem. We're going to talk about that a little bit as we go. And here's I think this is interesting. This just shows the likelihood of an application having a particular kind of vulnerability. And then on the right, it shows the likelihood of attacks on that category of vulnerability. So you can see attackers are pretty smart. They're focusing their attacks on the places where vulnerabilities are more likely. But they're not, they also focus on some things like you can see command injection. It looks like they're over attacking command injection. Well, the reason is it's such a powerful command. If you can exploit a command injection, you take over the whole host. So it's not surprising that there's more attacks on this. Expression language injection, increasing attacks here. This is really powerful attack as well. This is what Strut's problem that caused the Equifax breach. So definitely something to keep your eye on. But we publish these statistics every couple months so that you can continuously kind of keep track of where the biggest risks are, because it changes all the time. Don't rely on the OWASP Top 10 that was, it's several years old now, right? And it might be prioritized wrong for y'all. Okay, so let's get into it. So this is an instrumented basketball. It's called the 9450, and it's got sensors inside it that detect things like your dribble speed and the rotation of the ball and whether you make or miss shots. It can even sense the arc of your shot. So I'm a avid basketball player, and I started using this thing, and after just one session, one hour of using it, I got this great data in my iPhone app that said, hey, you're shooting the ball too flat. And I was like, well, that's interesting. No one ever told me that. And so I went to fix my shot. I changed my game and it improved my shot. The reason I say instrumentation changes everything is it changes the relationship between player and coach. So if I can get a basketball and just learn on my own and do this by myself and get great feedback, I can improve my game a lot. Now, it doesn't mean we don't need coaches. It would be cool if there was a coach that was tapped into my data here and monitoring how I was doing and how I was performing and maybe giving me extra things to do on spots where I need help. But these kind of sensors can really change the game because there's not enough coaches for all the players out there. It's kind of the same thing in healthcare. Many of you may be wearing Fitbit or wearing an Apple Watch or carrying an iPhone or something. Those devices are going to monitor your health in all kinds of new ways as we go forward. They're probably going to know you're sick before you do. And imagine the data that we can collect. People can get treatment faster, get treatment better, and doctors can do a lot better job because they can scale their efforts much more effectively. And we get this public health data, which, if, for instance, there was an epidemic, it would be really useful to have awesome monitoring of all the people who might be sick out there so that we can respond much more quickly. Instrumentation changes the game. It changes the math between expert and practitioner. And so the problem that we have right now is exactly this. We got way too many developers and way too few real application security experts. So we've got to do something. We need a force multiplier to help. And I really think that instrumentation is the key to unlocking that. So let's dig into that a little bit. The good news here is that software instrumentation is easy. People have been doing this for decades. Mostly people do this to add logging or performance metrics to their applications. So tools like New Relic and AppDynamics you might have heard of, they do a great job at this. They're using instrumentation to give really fast, really detailed feedback back to developers. And the cool thing is you can instrument applications yourself now. So in Java, there's something called the Java Instrumentation API. And this is kind of a diagram of how it works. And other languages, in .NET, there's a profiler API. In other languages, there's other ways to instrument code. But imagine if we could add some security sensors directly into an application, like as it starts up, so that as the original code, as it existed on disk, we're going to load it. Normally, this would go straight through into memory and just start executing. But imagine we could intercept that. We can hook this call, and we can add sensors to this code that's being loaded. So then when it gets into memory, we're going to run the instrumented code. And the instrumented code is all perfectly valid code. It's exactly as if you had built those sensors into the source code, but we're going to add them to the binary as it's loaded because, just from a process perspective, that's easier than trying to have all the developers in the world add this instrumentation to their code. We can do it at load time and put these sensors in very surgically, exactly where we want to put them inside the application to detect things that we might be interested in. So it's really that easy. And I'm going to show you now how you can write your own sensors, your own agents to add this instrumentation to applications, and you can learn interesting things about your applications. So this is kind of how I think about it for security. When we add these sensors into the application, it's like having a friend or an ally or an agent, actually, inside the application that can feed us data that we want. So imagine we're pen testing an application. Normally, when you pen test stuff, you're kind of blind. In fact, somebody once described pen testing to me as staring up the shower to find a problem in the water heater, because it's really difficult to imagine what's going on. Here, imagine you're pen testing, but you've got a buddy inside the application that's watching what's going on. So if you send in a SQL injection attack, your buddy can go, no SQL, nothing happened. Or your buddy can say like, hey, you nailed it. It looks like that data that you sent in the query sent in the HTTP request showed up in the query. And here's the full query as it happened. That would be super useful. It would make you an amazing pen tester. It's like cheating because you've got insight. And as we go forward, I hope you can see that there's nothing that we can't access with instrumentation. We can learn about the code itself. We can access the configuration. We can see library calls. We can see data flow, control flow, all the backend connections, queries, access to the local operating system, local file access. Anything we want to learn about from a security perspective, we can extract that data with a sensor and spool it back to the, whoever we want to need it. So I see this changing the relationship between security expert and developer. In this case, imagine that the security expert is, they spend their time, instead of like chasing the next cross-site scripting flaw, imagine they spend their time more strategically saying, hey, we need a sensor to test for this custom access control scheme, or to make sure that developers are using our custom encryption library right, or just to make sure that they don't introduce an expression language injection or whatever. But as a coach or toolsmith, the security experts can define the rules. Everyone else can benefit from the feedback. And I'd say the biggest advantage of this approach is that it's directly measuring what I call the runtime reality. This is the fully assembled and running application or API. It doesn't really matter to instrumentation. It has everything all put together, fully assembled, with real data flowing through it. And that's critical to making good decisions about security, because what's in your source code repo is not necessarily what runs in production. Not counting all the libraries, but there's also, all the pieces that get added in at runtime from the app server and the platform, like the version of the platform that you use, like Java 1.6 or 1.8 or whatever. And there's a lot of things that change behavior based on those environmental concerns. So I think measuring the running application is the only real way to be accurate. Okay, so let's talk about the Java Observability Toolkit. This is a free and open library that I created over the course of the last year or so. And what I was trying to do is make instrumentation more accessible to everyone. It's not that hard to do it the manual way, but I wanted to make it something that everyone, even security folks that weren't really, like hardcore developers, could use to extract information out of applications. And notice it's not the Java Security Observability Toolkit, it's the Java Observability Toolkit. You can use it to measure just about anything in a running Java application. And yes, I should have a .NET Observability Toolkit and a Ruby Observability Toolkit and Python and Go and all that. I'm looking for help to do those things because I don't have time to do it all. But I want to show you some examples of how you can use instrumentation to revolutionize the way you think about application security. So we're going to start with a ridiculously simple example, almost like a hello world example of just finding weak SQL queries. And a weak SQL query is not necessarily exploitable. It's just one that doesn't use a parameterized interface. So, if you're in a company that has a policy that says you should use parameterized queries everywhere, then this is a great rule for you. You could deploy this easily across all your application servers. And by tomorrow, you could have a database of all the places in your enterprise where you're using unparameterized queries. They may not all be exploitable by SQL injection, but you can gather a lot of data really fast this way, all in parallel across hundreds or thousands of applications. So this on the left here, on the left here is called a JOT. It's a YAML file that just specifies a set of sensors. In this case, just one sensor. And the way you read this is, we've got a name and a description for this, and we list some methods that we want to put a sensor inside. So these are the 4 ways of sending an unparameterized query in Java. And I realized later, after I built the first rule, that prepared statement extends statement. And so I want to exclude that, because otherwise this rule would instrument that as well, because it instruments any drivers that implement this statement.execute. We want to instrument all of them. So if you're using MySQL or whatever, we want to make sure we instrument all the right specific versions. This is the interface, but we want to instrument all the actual implementations. So we exclude Java SQL prepared statement. And then we're going to capture the arguments. So there's a number of things that we could capture here with this. This is actually a Spring expression, and we'll look at some more complicated things here, but we can capture the arguments. You can capture specific arguments like P0, the first parameter, or P1, the second parameter. You can capture the return from this method, or you can capture the object itself. So there's a lot of different ways of pulling data out. You can even, if you grabbed the first parameter, you could call a method on that first parameter to extract data from it, or you can chain method calls onto this to extract whatever you want. Anyway, for this one, all we're doing is we're just going to grab the arguments, which for these 4 methods happens to be the SQL query itself. There's only one parameter to this. So what we'll see over here is this data coming out. So I want to show you how this works in real life. So I've got a little application called Ticketbook here. It's on GitHub. It's a deliberately vulnerable application. It's got a bunch of little demonstrations of different kinds of flaws in it. So the first thing I need to do is download the agent. And so I've downloaded this jot.jar. You can get it right off the project website and GitHub. So it should be pretty easy. You download that. And then when you launch the application, normally I would just launch this by going Java. I would launch it by going in Catalina-sh run. Like normally I'd run it like this, but I'm not going to do that. First, I'm going to set an environment variable, and I got it typed out here so I don't mess up. I'm going to use this syntax to set this environment variable, which just says use this Java agent that I just downloaded, and use this jot file. This is exactly what I just showed you, that jot with the YAML in it. And that's it. Once I set that environment variable, then I can run this application the normal way. And actually, you can see here, when it starts up, jot prints a couple messages, and it says, hey, I'm instrumenting, I'm putting in this one sensor, and I'm instrumenting these several methods here. And then that's it. Once it's installed, and it starts up, the application starts up normally, and then I can just use it. And what you'll see is that Jot is dumping out all the queries that happen here. So I'm going to go to this check page, and I'm just going to put in, let's see, OWASP Toronto. How about that? Toronto. And hit submit, and you can see Jot tells me, hey, we've got a new query that is unparameterized, and it uses this data from the from the HTTP request that I just sent in. So you're probably thinking SQL injection, and actually, if we try to exploit that, I just put in a simple SQL injection attack. You can see, hey, we are actually exploitable, because you notice this changed now from anonymous to Jeff Williams. That's because I'm the first one in the database. And so, then I can use SQL injection techniques to iterate through all the entries in the database. So that's bad. Here's a quick quiz. For all of you watching at home, what other vulnerability is likely to be in this page right here? I don't know. Put it in the comments or something so that, and Paul, I think you're going to have to tell me if somebody types it in.
I'll check now on the feed.
See if we've got some pen testers on the line.
Hey, Jeff, it's Paul Keeter. Any chance you could zoom in a little bit on the terminal up just to make it a bit bigger? My poor old eyes don't see so well.
No, great call. Sorry about that, everybody.
Thank you, Jeff.
And I just we have a one question.
Yeah, shoot.
For Ebro. Wow, I'm a huge fan of Contrast. Had to repeat that, of course. Nice to have you on the session. Please expand Contrast to work with Scala and Kotlin languages. Yeah,
I'm super glad you mentioned that. So Contrast currently works with Java. So Kotlin and Scala are not that difficult for us, and we are adding them. So you can look for that sometime relatively soon. I'm not allowed to make specific predictions about dates, but it's definitely something we're working on. We also support, just for the record, we support .NET, .NET Core, Node.js, Ruby, Python, Go, and let's see. I think Scala is this year for sure, and maybe PHP. So we're covering quite a broad swath of languages. So did anybody make a prediction about what kind of vulnerability this is? Another one that's in this page?
I'll say struts.
Oh, no. It's a good guess. We'll talk about expression language injection in just a minute. But if you just look at this page and your spider sense is highly attuned to vulnerabilities like mine, then you'll see a pretty obvious possible vulnerability here.
So in the chat, I think John K suggested XXS.
Exactly. So cross-site scripting is the obvious thing here. When you see data that I type in here get reflected back to the web page here, you should always be thinking cross-site scripting immediately. And sure enough, in this case, if we put in something like this, sure enough, it's vulnerable to cross-site scripting. So I always try to point that out just to get people, like, you want your spider sense to start tingling anytime you see that. And if you enter things like even just bold, if your data comes back bold like this, then it's probably susceptible. That's an HTML injection, is probably vulnerable to cross-site scripting. Anyway, so just file that away. Okay, so
sorry, another question was, what was the 1 = 1 / A = A in the query about? From Mike Curry.
You mean just what was this exploit?
It says, what was the 1 = 1 / A = A in the query about ?
Oh, yeah. So this is a SQL injection exploit. And instrumentation can really help us understand this. So like normally when I type in like Jeff into this query, you can see the query down here. I'll bring it up. Oops, shoot. I'm going to try to bring it up a little bit so you can hopefully read this. So you can see the query and you can see where the data is landing in the query. And so, some queries are pretty complicated. This one's real straightforward. So I can see if I want to inject into this query, I need to put something in between these single ticks that will, allow me to change the meaning of the query. So I know the first thing I need to put in there is a single tick character, because that's going to close the query. And look, if I send just in that, you'll see I get an exception because I've got, now I've got 3 single ticks in a row. But I know I've probably got injection because I changed the meaning of this query. So now you're just trying to get the syntax right. So I'll put in my single tick, and then I'll put an or 1 = 1. And notice I'm leaving the last single tick off. So when I submit this, that data lands in the query right here. And so this is the data that I entered. And you can see it drops right in there and creates valid syntax SQL that has this or 1 = 1. Now, or 1 = 1 always evaluates to true. So essentially, this reduces to select star from tickets because the where clause is always true. So that means I'm going to get every record out of the database.
Mike also says, yes, try a union for that. I don't know if that's relevant if I missed that comment earlier. So it's tough to see the timeline.
I mean, once you can inject into the query like this, the game's over. Like I can do anything. I could, sub-select, union other tables. I mean, you may want to use a tool like SQL Map to point it at this flaw and figure out how to exploit it. But that is all not the point of today's talk, right? SQL injection is super fun, but today's talk is about instrumentation and how very quickly we can identify this kind of vulnerability. Later, I'll talk about how we prevent this kind of vulnerability from being exploited, which is kind of cool too. Okay, so let's move on to the next example. So that was super simple. Another thing you might want to know is like what encryption is happening in an application. And actually, I dare you to run this, because if you run this simple sensor, you will get a huge list of ciphers. So you can see here, we're extracting P0, which is the name of the cipher in this get instance method. So we're just putting in a simple sensor into the get instance. We're going to dump out the first parameter again, just like the last one. But here we're going to make a little table that kind of counts up. So Jot has some reports built into it. So here we're going to build this little table that has encryption usage. It'll show you where in the code, and it'll show you all the queries, all the ciphers that are used at that point. So here you can see this is just using the application. And oops, sorry, I didn't mean to advance that. Using the application normally, and you can just build this table. And I'll demonstrate it quickly, but I think you probably already got it. So I'm going to just
John K. just mentioned SQL injection dash whatever the account has privileges for, funny face emoji. Fun stuff. I love seeing the instrumentation show us what's going on. There's a comment from John.
Yep, thanks. So here I just changed to this ciphers.jot, and I'll just run the application the normal way again. And now when I use this application, it's going to, as I just click around and browse through these different pages, it's going to fire those sensors and tell me what's going on in the application. So you can see I've hit a couple pages. So you can see I found some single DES, some AES, some password-based encryption. And as I go into some of these other pages, you can see there's more types of encryption in there. Triple DES, DES with cipher blockchaining, and so on. So look, when you use these on real applications, you're going to find all kinds of encryption and hashes in your applications. Lots of MD5, lots of SHA-1, things that we think are weak and shouldn't be used anymore, but they're everywhere. So this is a way of getting insight into all that. So with that, let me switch to another example here. This is my favorite example. Well, it's one of my favorite examples. So this is a little more complicated of a Jot. You can see we're going to use 3 sensors here. One to get the routes for the application. That's like all the entry points. Then we're going to instrument the service method once to get the first parameter, which is the HTTP request. And we're going to call get request URI on that. So the first thing we want to do is that's how we get the route. The second thing we're going to call get users. We're going to make a rule for getting users. We're going to do the same thing. We're going to call the HTTP request and call get remote user on it to get the currently logged in user. And you can see up here, it's like guest user ABCDE. And then the last one is getting their role. And this is really cool. This is if we ever see an isUser and role call, which is a built-in access control check in Java EE, we're going to log the name of the role that's being required at that point in the code. And then we're going to build some tables out of it. So let's take a look at how this works when we actually run it. So I'm going to set my variable again and run the application normally. And then I could even make that a little bigger, I think. This has a bit of data coming out. So with this one, as I browse around, you're going to see a few routes show up in the test coverage matrix. Now, just think how valuable just this would be when you're doing a pen test and you've got a buddy on the inside keeping track of all the pages you hit and all the roles that you've hit it with. Really powerful stuff. But when I go to these access pages, I'm just going to click on A, B, C, D, E here. And you can see contrast, detected all those as part of the route coverage. But also, we started building this access control matrix. We see that page A has a check to see if you're in role A. Page B, role B. Page C, role C. But notice page D, which I clicked on, by the way, like I'm hitting page D here, but there's no access control check in page D. Wow, that's probably an oversight. What's going on? And then in page E, you can see there's 3 different access control checks, one for role A, one for role D, and one for role E. Now that might be right or it might be wrong, but that information is incredibly difficult to get. if you want to test this kind of access control with a pen test, you've got to log in as role A and hit everything in the application, then log out and log in as role B and search to see if you can access any of the pages that role A could access. And it's almost impossible to do comprehensive access control testing. I used to specialize in this, but it can take days or weeks to even get started on this. So this is really powerful. You should be able to take this access control matrix and show it to the development team and go, hey, is this right? And they should be able to fairly easily see problems. Then, of course, if I go to like role C, I can switch between users here and start testing these pages. And you can start to get a sense of like, oh, now I executed all those pages with user A. If I switch to another user and click on these, maybe user C, I can click on a few of these. User D, I'll click on a few, and then user E, I'll click on all of them. You can easily see gaps in your test coverage. Look, I should probably test user C here, this page C, with user C, because I know that there's an access control check for user C on that page. So that means I've got a big gap in my security testing that hasn't been done yet. And look, this only took a few minutes. It's not hard to create these sensors. It's not hard to run applications with them. And then you get all this data. So I think of this as like almost, this one I think of as kind of a middle ground between, like not doing any access control testing and doing like penetration testing where you'd find problems. This is like a middle ground where you're just making application security visible. Remember I talked about observability at the front, the job observability toolkit. This is about making security observable so that everybody can just make some smart decisions about this now. They'll have all the data to do this right. Hey, Paul, if there's any questions, please feel free to just jump in. I think this is really important, really powerful stuff. So I want to make sure this connects with everybody. Can somebody say something? Make sure I'm still here.
Yeah, you're still here. I think, Paul, you're on mute.
My apologies. I was on mute. Sorry about that. Sorry, your timing is impeccable as always. We do have some questions, so thank you, Jeff, for the pause, and my apologies for the mute. Dennis asks a great question. In a more real-time environment where other controls like WAF are in place and in theory working as it should, what benefit could this provide? ?
Yeah, that's a great question. So far, we've been talking about using instrumentation to detect vulnerabilities. Usually you want to do that in pre-production, in development and test environments. Something like a WAF, you would use in production to detect attacks and block attacks. We'll talk about how you can use this to block attacks in just a second. But right now, we're kind of focused on the pre-production side of things where we're detecting attacks. Where we're detecting vulnerabilities so that development can fix them before they get into production. So let's put a pin in that one for just a second. We'll get to that in just a second.
One other comment Ebro makes is, this helps for code review too. I wish it supported more than Java. Can this be easily integrated with CI/CD?
Yeah. So look, we need this kind of toolkit for every language. I can't build them all. So, that's why we built Contrast to do all those languages. But, we don't have an open source observability toolkit for every language, but I'd love some help. Yeah. It's not a huge project, by the way, to build the observability toolkit. I mean, you can look at all the code. There's not a massive amount of code. It's just getting the right bits. And in terms of integrating this into CI/CD, absolutely, that's a great place to put it, because this instrumentation runs silently in the background, doing what it's supposed to do, and it doesn't require any interaction. So as you run your normal test cases, this Jot can be there finding stuff as you do your normal work.
Yes, I just we have customers doing this today in other languages as well.
Yeah. So I put these little diagrams together to show, this is another thing that Jot can output. Maybe some people understand it better this way, but if you think about this route, check.jsp, this shows all the sensors that this flow through the code hit as it executed. And so here you can see, like, we came in the front door, we called get parameter, and we got this ticket parameter with the value 10,001. Looks like it got called twice, actually. That happens sometimes. And then there was an unsafe query here. And, you know, if you're smart, you can see, like, look, that data probably is that same parameter got filled in there. Actually, later we saw the use of single des, and actually later on than that, we saw expression language call get evaluated. But, you know, this is just all the things that happened within the course of executing this one route. Same thing here with an expression language injection. You can see, you know, just normal stuff happens, and then this expression gets called with this parameter, this, what does it say, midwinter, and that word midwinter ended up in the expression language evaluation. So hey, maybe that's exploitable. And then this last one is, you know, it's a command injection. The real interesting part is up here, but I wanted you to see, like, under the hood inside runtime.exec, all this stuff happened. There's an RC4, des, triple des, AES, all this stuff happens while we're doing a runtime.exec. And there's some reliance on SSL here when we're doing this, starting up this calculator program. So it's just interesting that that's under the hood there. You discover all kinds of things when you start using instrumentation. This next idea, I think, is really powerful. So many of you may probably used some application security tools that generate a report, like it's probably a massive PDF report full of vulnerabilities. That is not an effective way to communicate security to anybody, much less developers. So, you know, you think about all the ways you might get a vulnerability that you discover to a developer in a way that they could understand it. Like, you might give it to him in a report, you might give it to them via dashboard, you might give it to them via Jira ticket, you might use like a Slack alert or something, or you might have it show up in their IDE. None of those are ideal because they really don't, you know, they're not part of the normal workflow, right? Like if you got to go to a special plugin in the IDE or run a special step in the IDE, like none of that is perfect. So with instrumentation, you can actually fail test cases that have security problems. So, you know, the normal way for developers to work is they run their test suite. If the test passed, their code is good, they can check it in. So here's a way of, you know, with this little sensor, you can make a jot that causes any test cases to fail if you use some banned call. So you could put a list of methods in here. Right now, I've just said, hey, you're not allowed to create native processes. That's a simple rule. We'll fail any test case if there's a native process gets started inside it. But, you know, maybe we want to have a longer list here, or maybe we want to do something more complicated. Like we can have much more sophisticated detection. Like, hey, we should fail test cases if there's a unsafe use of SQL, or if you're parsing XML with a library that allows external entities for XXE vulnerabilities, or whatever. The point is, failing test cases is a great way to communicate with developers because that's how they expect to run. So here you can see when I run the tests for this, you can see this exact message that we put in our jot. That exact message shows up to the developer right inside their test suite and shows them exactly what they need to do and the exact line of code that the problem is on. So it's just a powerful way of communicating with developers, and frankly, it's something that we need to do a lot better at. I'll show you this. You should check out this link if you're working in application security and you want to know how to write up vulnerabilities a little better. I'm going to go to this real quick because I want people to be familiar with this. I spent, you know, almost 20 years doing this, and so I shared my thoughts with how to communicate vulnerabilities. So this article is about this technique for communicating vulnerabilities. I also wrote one about, we're gonna have to get to it in a second. I'll come back to that. A nice one about communicating with developers and writing up findings. We'll talk about that in a sec. Okay, so this one's cool. This is expression language injection. And here, we're going to switch from detecting the vulnerability to preventing it from being exploited. It's really powerful. Notice our YAML here. This is the only bit that really matters here, is this red highlighted bit. We're going to put a sensor into the process builder and the socket interfaces in Java. So we're going to prevent people from, if they get an expression language injection, they're going to be prevented from creating native processes or opening sockets. You could prevent them from opening files and all sorts of stuff. But I just kept a minimal list here. And we're going to put a scope on it. We're going to say, if you're trying to do these things from within the evaluation of an expression, then we're going to throw this exception and we're going to stop this from happening. So again, pretty simple rule. This would have, if people had this when the struts vulnerability came out, they would have been safe. It would have prevented struts from being exploited. So let's take a look at this. So I'm going to go into this EL example here, and you'll see this field just reflects back into the page. And so, if you're thinking XSS, you're probably right. I haven't tested it. But this field also is an expression. So if I put in something like, 1 + 4 here and submit that, it'll get evaluated. That's really dangerous because now the attacker is causing this, very trivial code to run. But sure enough, attackers are pretty creative, so they figured out how to put in more complex expressions. And here, if you do something like this, like runtime.get runtime .exec open-a calculate. This is injecting a command to natively run the calculator program on my machine, the server. So here you can see I was able to start calculator. So now I know this is a brutal attack. And this is almost exactly what the struts attack on Equifax did. They used a header, but they put in an attack that was pretty similar to this with a few extra steps. And that's how they did it. So let's try running this now with our expression language injection JOT. Let's run that application normally. And this JOT, again, this JOT injects into the runtime, runtime.exec here, and we'll test to see if we're inside an expression, then it'll prevent it. So first thing I'll do is I'm just going to test to see if this is still evaluating expressions. Yep, sure enough, it's not preventing all use of expressions. We can run expressions, but if we try to put in a malicious one that does a runtime.exec, JOT will intervene. It'll say, hey, we detected an expression language injection attack, and we're going to block that from executing by throwing this exception. It's actually called a sensor exception. We're blocking that. So that's a powerful technique. So, in just a few minutes, we've shown how we can use instrumentation to find vulnerabilities, to create security observability, and now we've seen how we can use it to detect attacks and prevent them from exploiting an application.
Just a couple comments.
Yep.
Ebro asks or comments, can you whitelist alerts / findings? And an earlier comment from Ebro, perimeter security is not reliable, IMO, ha ha ha.
Yeah, so you can make you can tune your sensors to allow or disallow different alerts if you want. Again, JOT is like it's a library that you can use to create your own sensors. And there's a bunch that come with it. I think there's probably, I don't know, 50 sensors or something that come with it. But you can create your own and you can tune them and tailor them yourself. The second question is, I don't know if they're agreeing with me or not. They're saying perimeter protection is not effective, and that's exactly right. This isn't protecting at the perimeter. This is protecting from deep inside the application, where you have all the context that you need to be really accurate about whether this is an attack or not. So it's very different than what a WAF does. A WAF would have difficulty detecting this attack because there's about a zillion ways of doing this attack. When you put in this expression in here, there's a ton of different ways of making this expression happen. I mean, it's like, open code from here to here, and you don't even have to put in, $. You can put in a hashtag, and there's a bunch of other ways of putting in expressions to make this really difficult to detect on the wire. So that's why we detect it from where we know it's an attack, where it has to be an attack, because no expression should ever be opening sockets and running native commands. Okay, so that's expression language injection. I think that's my last demo. So I got a few other comments. I want to make it a little like terminology. So there's a type of application security tool called IAST that stands for Interactive Application Security Testing. And all that means is that kind of tool uses instrumentation to detect vulnerabilities. And you use it in development. It's passive. So, anyone can use it. You can turn all your developers into security testers, just like that instrument in basketball can turn every basketball player into Michael Jordan. Well, we can turn developers into security experts by giving them IAST and letting them use their own, find and fix their own vulnerabilities. And it does exactly what we talked about. It's a little more sophisticated than JOT usually, but JOT is IAST. It's a very simple version of IAST. And then there's RASP. RASP is Runtime Application Self-Protection. And all that means is that it's a tool that uses instrumentation to detect attacks and prevent exploits, just like we did with expression language injection a second ago. And you typically use that in production. It's very fast and provides really accurate coverage. So if you're tired of tuning your WAF every time your application changes, then RASP may be something to look at. So IAST and RASP can be the same agent. That's what we do in contrast, or they could be different agents, but they both use instrumentation to protect the whole application lifecycle. So really what we've done is we've moved away from this scan and firewall model, this outside-in kind of model, because it's disruptive. Like scanning and firewalling are both really inaccurate because they don't have all the context that they need to make smart decisions about whether something's really a vulnerability or really an attack. That's why static tools generate so many false positives, and DAS tools, it's really hard to get coverage. You need experts involved with those tools, or you really can't, and that prevents them from scaling. So I believe the key to really getting to DevOps and DevSecOps is to move to this embedded model where you're taking advantage of instrumentation. The downside is that you have to do a little bit of work to add the agent to your test environments and your development environments. But you saw it's not that hard, right? I mean, it's really just like that. You add, one thing, one little jar file to your environment, or, for .NET, it's a little installer or whatever. But you add it, and then security happens automatically in the background as you're doing your normal work. And so now you can, it's kind of a force multiplier to get all your developers doing the bulk of the security work. Security folks can take a more strategic role, maybe focus on things that are more critical, like threat modeling and security architecture and threat intelligence, and use the big machinery of software development to do a lot of the security work. And frankly, they'll be happier about this too, because they can push code into production faster because they have confidence that it's secure. So when I think about it, it's a little bit like this. Like you add the agent into your factory. Like a lot of times you can add it strategically, like to your standard server build or your cloud environment or whatever. Cover a lot of applications. You add it to your app servers, and then the data that comes from that agent flows into a central dashboard. Like you could imagine with Jot, you could take all the telemetry that's coming out of Jot across, dozens or hundreds or even thousands of applications and bring all that telemetry into a dashboard where you can see trends and you can manage metrics and you can improve your application security over time. And this all happens continuously. It's not like you have to, wait a few weeks and then run a scan and then wait for the scan to complete. And then some team has to triage it. And, a month later, you get back findings to developers that they just put in a big repository or it goes in the backlog and nobody ever fixes it. We're trying to make that feedback loop really quick. So, that's one of the big advantages of instrumentation is it's real-time communication. So I think of it like this. If you inject security into your applications with Jot or IAST or any other RASP, you can do SCA with RASP as well, by the way. It has some big advantages. You can see which libraries are actually being used and focus your efforts on those. And then once you've injected it in, you just do your normal development process, and any vulnerabilities or attacks that are detected get reported back instantly. And ultimately what we're wanting to do is accelerate this pipeline. We want to help teams push code into production faster without sacrificing security. And so that's why this full automation is really, really important. Ultimately, that's the key to DevSecOps. And a lot of people are out there talking about DevSecOps, and probably every vendor claims that they are the solution to DevSecOps. But really, at the core, DevSecOps is about, just exactly what's in the Phoenix project. It's about breaking up security work into little pieces, automating it to create tight feedback loops, and creating a culture of experimentation and learning. And instrumentation can do that. Once you take care of the OWASP top 10 kind of stuff, you can start creating your own instrumentation to check your own security controls, like your custom access control scheme and your custom authentication scheme. You should create JOTs for those and test them automatically so that then if anything ever goes wrong in the future, you'll get notified immediately and you can fix it. And we've seen this work. This is an example from a really large insurance company. They were using SAST tools, static analysis tools, and their median remediation rate was 121 days, so like 4 months. And they were getting to 71% of the vulnerabilities were getting closed in a year. We switched them over to IAST, and they were achieving much faster rates. If you can see the green line here is, median is closed in 7 days and 61% are closed in 30 days, 90% by the end of the year. We're super excited about that. And this white line is actually what's got me incredibly excited. This is for projects in this organization, and this is across 700 apps. For projects in this organization where they've worked off most of their backlog. So, initially when you turn on a security tool, you get a flood of vulnerabilities, and some of those take a little while to fix. But once you work through that backlog, the real measure that you want to focus on is how fast are we fixing new vulnerabilities that we just introduced and we just discovered. Here we found that for those projects, they're closing 75% of them within 8 days. That's really fast. That means we know that this feedback loop to developers is working, and a lot of the vulnerabilities are getting fixed in a day. You can see in actually 50% of them on the white line are getting closed within a day. That's really exciting. That's a very different change that I haven't seen in this industry until now. So I'm super excited about that. MTTR is the metric you ought to be looking at, in my opinion. This is how you measure whether you've shifted left. And this chart shows whether you've shifted left. And shifting left is the most cost-effective way of doing AppSec. So that's why I'm hyping this so hard, is because it's really important. If you want to get better at AppSec, You have to stop letting vulnerabilities sit around for 4 months, and you have to get them fixed right away. Otherwise, your program's going to fail. So with that, I think, to me, these are the keys to DevSecOps. Empowering developers, as we just talked about. Let them do most of the security work themselves. Check in clean code, and hopefully give them permission, if they've done the right stuff, to push code into production at whatever velocity they want to go. We want to make sure that that's fully automated, right? So we need to integrate this into DevOps pipelines. I don't understand why people don't have RASP in their stack. RASP is fast and accurate and prevents a world of vulnerabilities from being exploited. There's a number of different products on the market. Ours is just one, but they'll all stop things like SQL injection and XXE and expression language injection and cross-site scripting and just a variety of command injection. I mean, all the most serious vulnerabilities, RASP will stop them cold. So I just feel like you'd be crazy to operate without runtime protection in place. And even if you don't want to put it in blocking mode, at least put it in monitor mode so you know who's attacking you and what systems they're targeting in an accurate way, not like the noisy WAF way. And then the last piece to DevSecOps, you need that management support. You want to make sure that your management team is focused on creating these tight feedback loops and this efficient DevSecOps process. That's a whole different talk. I'd be happy to do that one another time, but I really want you to consider putting IAST and RASP into your stack so that a lot of the work that we do in security will be automatic and just part of the normal development process. If you want to try it, you can try full strength IAST and RASP and SCA. We have Contrast Community Edition. It's available. You can use that on one application for free, and give it a try. See how you can do application security by just using your application normally, and just imagine how that can make a difference in a large-scale AppSec program. So with that, I did want to pimp my articles here. So this one, How to Vulnerability, is it's really a great how-to article on how to write up vulnerabilities in a way that's compelling, that will get developers to both believe the finding and make the change that you need them to make. I'd be willing to bet, even if you've been doing this work for a while, that you'll learn something by reading this article. I've trained certainly dozens of consultants how to do this over the years, and I think I've made all the mistakes that are possible, so that this reflects that a little bit. And then I also wrote up a pretty comprehensive article on how to get to DevSecOps in a large-scale enterprise. Most DevOps articles are about doing it on one project, but I really want you to think about the whole software factory. And some people don't like that term, software factory, but I use it to convey the idea of lots of pipelines, lots of apps, lots of code, lots of servers, lots going on, not just a single SDL, because that's not reality. No company has just one SDL. So when you back up and look at the whole factory, there's some strategic things that you can do to try to achieve DevSecOps. I think I sent the deck already, Toronto folks, so please go ahead and make that available. And with that, I'll stop sharing and see if there's any questions.
Yes, I will absolutely share that, Jeff. Thank you so much. Appreciate the time today.
Thank you. Well, just checking
everybody,
to see if there's anybody asking questions.
Okay. Yeah, I can't see any questions that are out there.
Yeah, I think you answered most of them.
Okay, Adam, what are your thoughts?
Yeah, I mean, I've kind of played around with instrumentation before, like with the Frida framework.
Oh yeah.
Yeah,
For
I guess
mobile apps.
Yeah, exactly, mobile apps, but it also kind of extends to desktop apps as well. Yeah, how does your tool kind of compare with the Frida framework?
Yeah, it's kind of similar conceptually. Free to the difference is kind of the target of the instrumentation. We actually partnered with NowSecure. They were instrumental in instrumental in getting the Free to framework out there, and they have commercial products there. So when we don't do mobile security and they don't do web apps or web APIs, so it's a nice partnership with them. But it's the same idea.
Yeah, exactly. I mean, it really kind of helps to do get into the nitty gritty with web applications and mobile applications. So yeah.
Well, let me know if you try Jot. It's a fast way of experimenting with instrumentation. There's really not many questions that you can't answer with instrumentation. Spend the time, create a few sensors, and you'll learn something.
Yeah, certainly. It's kind of like when we do penetration testing with the using and manipulating requests to HTTP, it kind of gives you that back end knowledge that we don't really have unless you have that source code available. But it can be pretty, I guess, time consuming and difficult to dive through a deep code base of code.
Yeah, some of the sensors that come with Jot are designed for pen testers. So there's one that will tell you for each route, it will show you all the parameters that are possible for that route, even if they're not present in the HTML and don't get generated. So like if there's a hidden parameter that says is admin or unlock secret functionality, you'll see all those parameters. There's a bunch of others that kind of show you things that you'd be interested in as a pen tester.
Yeah, it definitely sounds really nice. I'll have to check it out.
The only trick is you got to get the people that you're testing, you got to get them to agree to put the agent on there.
Yeah, that's right.
But they should, they'll get a lot better value. So anyway.
So Jeff, just a couple of comments that came through. Just a comment, wonderful talk, a little smiley face, somebody enjoyed it. And I think one just came through from John. I love the talk. I want to learn more about contrast. I will check it out. Yeah,
Cool.
We now have a presence in Toronto. I am the regional sales manager for Canada. So if you're interested, and Paul Keeter joins me. He's the Canadian SE systems engineer. And you can approach us through the website or through the OWASP.
I'm sure they would love to show it to you.
Yeah. Paul Keeter is amazing too. So if you have questions about things, security tooling, please reach out to him. Yeah. Jeff, I did have kind of a peripheral question.
Yeah, shoot.
You're all over the place in the AppSec field. What else are you working on outside of contrast? Is there something else that you're like, oh, this is my side pet project that I'm also working on?
Oh, that's a great question. So I've got 4 kids. I'm working on making sure that they turn into good little humans. That's a big project. I have a wife I like to try to keep happy. I'm also learning to one wheel. I don't know if any of you have seen one wheel. It's it's kind of skateboard size, but it's got one big wheel in the middle, and you can go on bike trails, on terrain. Check it out if you. It's super fun. It's like surfing or snowboarding on like streets and fields and stuff. It's really fun.
We have a guy in our neighborhood. He actually does it, and he goes very fast. I've got to say.
Oh yeah, it goes fast enough to get hurt. That's where it starts getting interesting. Yeah. Oh, I do play a lot of basketball. I just
I can see that. Yeah.
I just my team just won the national 50 and over basketball tournament down in Florida. So that was exciting. We're kind of proud of that. So. Throw that out there.
Congratulations.
So if anybody wants to play basketball at Black Hat, I'll be out there. It's a lot of fun.
Nice. And then do you have any advice for people who are starting out in the field?
Oh, yeah. Great question. So I did write an article on LinkedIn about exactly that. Nice. Let me see if I can find it real quick so I can tell you the title. It's so you want to be a pen tester or something like that.
So while you're doing that, Jeff, I just have to say I got to pick me up one of those basketballs.
Actually, I think I sell a lot more basketballs than I do security stuff. But
I want to become a pen tester.
Yeah, I found it here. I'll share it real quick. Oh, I can share the link. I was going to share the screen. That's stupid. I'll share it with you, and then I guess maybe you can share it with the crowd.
Mhm. Yeah,
Yep.
would love to, because there are some people in this crowd who are a little bit newer, and these are some of the questions that they usually ask or are a little bit too shy to ask. So
Yeah.
thank you.
No, it's actually, you shouldn't be afraid. Like my basic advice is, really learn how web apps work, and then focus on one kind of vulnerability. Like pick something that is either common or cool. Because once you let's say you got really good at testing for XXE, now you can contribute. You join a consultancy, you join an AppSec team in a big company or something. You can contribute. You can join a project and make a difference. You can test and say, "Yep, I found an XXE vulnerability," or "Nope, I checked them all and they're all safe," and that's really valuable. And then you can add the next vulnerability and the next one, and it doesn't take long to get the top 10. And then there's like 1,000 classes of vulnerabilities in MITRE CWE, so there's plenty of room to keep growing.
Nice.
I do have one.
Try some of the vulnerable apps. Like that's a great way to practice.
Yeah, I agree. Sorry, you okay?
Oh, I was going to ask a question to Jeff. It's related to IAST and RASP, and I just wanted to get your thoughts on how well it would work with single-page applications, and if you have any tips on how to configure your IAST and RASP for that.
Yeah. So you could do IAST on the browser side of applications, but generally people don't for a few reasons. Probably the biggest one is that there's really not that much risk there. The things that run in the browser are, the attacker has all of them anyway, and you shouldn't be putting secrets or tokens or sensitive data in the browser anyway. So there's DOM XSS, that's interesting, but for the most part, the risks are on the server side. And so for single page applications, that's usually a set of APIs. And instrumentation works fantastic on APIs because it's basically the same. The HTTP request comes in and it's not name value pairs, it's a XML document or a JSON document or whatever, serialized object or something. But once the data comes in, then IAST can track it and can watch how it flows through the API to see backend connections and all that. So it's really a very effective way of testing the server side of single page apps and mobile apps.
Awesome. Thank you.
Yep.
Any advice for people who are encountering resistance from people who are like, no, don't touch my code?
Do you mean from putting instrumentation in, or? Yeah, so you don't really need their permission. You're not changing their code. The executable is exactly the one that they produced, and so really you just need access to a test environment, and you can drop it in there, and you're not modifying it, right? You're just you're running it, and you're adding in some instrumentation, some sensors. They're passive sensors, so they generally don't affect the way the app runs. So most of our customers use IAST in their QA and CI/CD environments on their test servers, but some use them in dev environments. Developers can use it directly and discover their own vulnerabilities in the code they're writing.
Okay, cool. Yeah, just a lot of in-house security teams sometimes get a lot of pushback on anything having to do with touching any of the environment or any of that stuff. So
yeah, for sure. Really, that's a byproduct of the problem with AppSec in general, is that it's siloed. And the right path forward is to move application security inside. And that means inside the development teams, it means inside the process, it means inside the pipeline, it means inside the code with instrumentation. Being inside is the way to get the context to make it more efficient. But you need to plan out your DevSecOps transformation, and it takes a little while. If you get a chance, let's get Larry Maccheroni from Comcast up here to talk about it, because he did a really smart transformation at Comcast where he led them through a set of stages, each designed to move security in to various pieces, and it's really effective.
I'll put that on a list of people to reach out to.
Cool.
Okay. Thank you. I think that looks like it's pretty much it. So lots of great, feedback from various people just saying that they loved the talk. So thank you so much for spending the time with us and kind of moving the dates around a couple of times as well, and being so open to coming to speak to us. Do you want any last words from your team for the audience?
Please
Paul,
mute and so forth. Please feel free to reach out at any channel. My email is paul.kaiser, Kayser, contrastsecurity.com if you have any questions regarding Contrast and the enterprise capabilities that we have.
And I'd just like to thank everybody for showing up, coming out to OWASP, supporting the organization, and being a part of the future of AppSec. It's really important. I know you guys may be new to AppSec. We've got a long way to go. You can make massive contributions to this field. So, if you feel like you missed out on physics or chemistry or, aerospace engineering, you are at the birth of a really important sector here.
Yeah.
Your work can make a massive difference here. So, spread the word, contribute, speak at OWASP conferences, and it can make a massive difference. So thank you.
We got a comment from John saying he wants to keep listening to Jeff because he's amazed. It makes him want to become a pen tester, an application security researcher or something. So
it's a lot of fun, but it's hard. I mean, pen
problem.
testing work is hard because there's always time pressure. Everybody, it's like in that Castaway movie, like everything's on the clock all the time. So you have to be to be a really good pen tester. To be a shitty pen tester is easy. You just go hack for a little while and you write up a shitty report, and that's fine. But to be a good one, and I want you all to be good ones, you have to be systematic. You have to be like guerrilla efficient about planning the work, focusing on the threat model, designing awesome tests to verify what you want to verify, and getting done quickly so that you can move on to the next thing. It's not an easy profession, but if you do it for a few years, you'll be in a position to write your own ticket.
Absolutely. Great. Thank you. I won't keep you. Adam, any last things for the house?
I just thank you, Jeff Williams, for coming out, and I'd like to thank our sponsors as well. And the audience, don't forget to leave feedback, or if you're looking for CPE credits, the link's down below. Take care, everybody, and we will talk to you next month.
Yeah, connect me on LinkedIn.
Yeah. Thank you, Jeff and Paul.
Thank you.
Thank you.